Hi everyone, welcome to this video. In this video, we're going to discuss angle pairs. Now, angle pairs was started in a sense that we want to know first the structure or the composition of the angle. So, we're talking about two or more angles that is working with this one. So, and then followed by the pair of angles in relation to the measurement or their angle measure. So, let's start. So, the first thing that when we talk about angles is what we call adjacent angles. So assuming this is the points. So this is A, B, and then C, and then the vertex would be D. Now, when we talk about adjacent angles, so it should have common vertex and side. Now, in this illustration, we can find now three angles. So when we name the three angles, we have now angle ADC. When you can say angle ADC, this is the angle, which is the opening is from this side, AD, and then DC. Now, another angle is that we have now angle ADB. So when we talk about angle ADB, this is angle ADB, which is the opening, and the side that is working is side AD, or DA, and then BB. And then we could have now another angle, which is angle BDC. So angle BDC, as you can see here. Now, in these three angles, two are what we call adjacent angles. So those are small angles within a big angle. So, should be BB. Now, as you can see, these two angles are known as to be adjacent. Why they're adjacent? The two component is that they have common vertex and common side. Now, as you can see, this is the common vertex, which is D, right? And then the side that is common to them is DB or BD. So that is how you do now a adjacent angles. So what it requires you is to have a common vertex and a common side. Now, another example, if we're looking at this one, so naming this as X, Y, and then Z, and this is W, and then this is P. As you can see here, angle XPY is adjacent to YPZ because they have the common side, which is PY, and the vertex is this one. However, angle XPY and angle WPZ are non-adjacent. Why? Because it only has common vertex but not common side. Now, let's go to another example. Another pair that we need to look at on the structure. Now, continuing that, let's have now another color so that it will have a different sense. So, again, this is now your angles formed by two segments. So assuming that this is, that's point R, point S, point P, and then this is Q. Now, when we talk about vertical angles with common vertex. Now, this is now vertex K. Now, as you can see, there are two pairs of vertical angle here. So, the first pair of vertical angle is that this angle So, we can write that angle RKS and angle PKQ. So they're vertical. Another pair of vertical angle is that angle RKQ and angle PKS. So those are vertical angle. And then another implication vertical angles are equal in measure. So for example, if this is 70 degrees, therefore this is also 70 degrees. So if this is 80 degrees, this is 80 degrees. And then that's how it works. Vertical angles have the same measure. So those are the implication. However, we're now leading to the measures. So now let's go with the next part, which is complementary angles. I believe when you were in elementary, complementary angles was being discussed. So it requires that the sum of the measure of the angles is 90. So when we say 90, so it doesn't have to be, what do you call this, adjacent or non-adjacent. So for example, you can have this one. So this is a classic example. So assuming that this is 40 and then this is 50. So these two angles is what do you call this, complementary. But we can have it this one. This is 40 and then this is 50. This is adjacent but complementary. This is non-adjacent but complementary. Now we call each angles as its complement. So for example, what is the complement of 30? So if that is a question, in order for you to answer that, in your idea, you need to deduct the 30 from 90. So, brain, so 90 minus 30 is equal to 60. So, we call 60 as the complement of 30. So, that's how it works. So, for example, another example, what is the complement of variable x? So therefore, what's in your idea? 90 minus x, and this is now the answer for the complement of x. And that could be your conjecture or formula in finding now the complement of a given angle measure. Now let's go to another one. Another one is what we call supplementary angles. Now, a supplementary angle means sum of the angle measures is 180 degrees. So, when you look at now, remember if you have a straight angle, so assuming that this is a straight angle, this is already 180 in measure. Now, if there are division, like for example, this is 110 and this is 70, therefore, this is now what we call now supplementary adjacent. That is supplementary. But we can have it like this one. This is 70, assuming that this is 70 and measure, and this is 110. This is non-adjacent. Adjacent. So that is now how you look at now supplementary angle. It could be adjacent, non-adjacent. Now in solving, we call it supplement. So for example, if you have asked, what is the supplement of 50? So in your idea, you need to have 180 minus the given angle, which is 50, and the answer would be 130 as the supplement of 50. Now, another question. What if there is a variable? What is the supplement of x? Therefore, you need to write it 180 minus x. And this is now your conjecture or formula for getting the supplement of an angle. So that's how it works. Now, in this sense, we can now lead to what we call a vertical angle, right? So, given this one, this is assuming this is 80 degrees. This is x, this is y, and this is z. We can now easily find now the measurement of all the variables. So for example, giving now the reason to get now x, the reason there is supplementary. So therefore, you have now 180 minus 80. So this is now 100. So x would be equal to 100 as a supplement of 80. Now, getting now y. Y will lead you to the reason of vertical angle. So therefore, y is equal to 80 since what we find out is that one of the theorem is that vertical angle have the same measure. So y is equal to 80. Now, for z, we can only use now the given, which is 80. So therefore, we can now put that, remember, in context, this is supplementary, right? If you have a straight line, that would be supplementary. This 2 is supplementary, this 2 is supplementary, this is supplementary as well. So therefore, when you write that, this is supplementary in reason. Therefore, we can have it is that 180 minus 80 is equal to 100. Therefore, z is equal to 100. Now, let's go now to the last angle pair that we could have. The last angle pair in structure is a combination of structure and the measurement. We call it a linear pair. Now, when we talk about linear pair, it should be adjacent and supplementary. Now, when we say adjacent and supplementary, always remember when we have that structure, you need to have a straight angle, and then there would be a common side for the straight angle. So remember, it should be adjacent and supplementary. So for example, if this is 120, this is x, so therefore it should be 180 minus 120 is equal to x, and x would be equal to 180 minus 120, that would be 60. So that is now the requirement for a linear pair. A linear pair should be adjacent and supplementary. So I hope you learned something with this video. And then another thing that I want to give like fun fact, like assuming that this is now an angle, remember that the totality of the angle when you put this one is 360. So this might help you in analyzing now if there are some problems that requires you to find the measurement depending on the given angle structure that was working on. So let's have an example. If I gave you now Let's assuming that this is 50. No. Let's make it a little bit bigger so that will be a little bit. So assuming that this is 110, you find now x, y, and z. Remember that this totality is 360. It's much easier for us to solve for y because that is vertical. Y is vertical, so it's 110. So if this is 110 as well, so this would look like 360 minus 220. So 360 minus 220, that would be 120. So this would be 70, and then this is 70 as well. Remember, 180 minus 110, that would be, so x would be 70, and then z is also 70, because 180 minus 110. So that's how you solve now angles in relation to the angle pairs. I hope you learned something with this video. Thank you very much.